Hey, and welcome back to another LeetCode video. Today I'm going to show you how to solve LeetCode 846, Hand of Straights. It's a medium greedy problem, but it's quite interesting, quite an interesting one. So before we dive into the solution, let's first understand what we need to do. Well, Alice has some number of cards and she wants them to be rearranged into groups so that each group is of group size, which is the parameter that we're getting, and consists of group size consecutive cards. Given an integer array hand, where hand I is the value written on the ith card, and an integer group size, return true if she can arrange the cards or false otherwise. So the problem that we're trying to solve now is that given a set of cards, can we arrange them into groups of consecutive cards? And the groups have to have a specific size. So here's an example. So we have a hand that contains the cards 1, 2, 3, 2, 3, 4, 6, 7, and 8. And the group size is 3. So how can we group these numbers in groups of 3 in ascending order? That's what it means to have consecutive cards, right? Of card 1 follows card 2 follows card 3. That's one group, and in the result it is 1, 2, 3 is a group. The next group is 2, 3, 4, and the last group is 6, 7, and 8. So here the answer is true. And in the second example, we can't do that. You can see we have 1, 2, 3, and we have 4 and 5, but we can't combine them with anything else. So you can immediately see that because the group size is 4, so we'd have 1, 2, 3, 4, and then 1 left. So you can immediately see that when the length of hand is not divisible by the group size, we can't have a solution, right? So that's, well, we'll check that. So if length of hand and percent group, the modulo group size, is not 0, well, we're going to return false because we're done. And well, now the question becomes, okay, how can we, if it is possible to divide all of these hands and all of these cards into groups of whatever the group size is, then the next question is, can we get them such that the cards are in ascending order in each group? Well, for that, we're going to need a little helper tool here. We're going to need pretty much a frequency of every card to know how many cards of a specific type there are. And every time we're going to try to construct one of the groups, we're going to decrement the counter for that card. That way we can keep track of whether we've used all of the cards or not. So we're going to have a little counter, a dictionary. Just going to use a default dictionary for n in hands. Counter at position n is going to be counter n plus 1. So that's that. And now, well, what can we do now? Well, we could try to start to build the groups from the smallest number that we have. You know, we could determine the smallest number in our hands array in linear time. However, when we've consumed maybe the smallest number, then when we try to build the next group, maybe the next smallest number has changed, so we can't call minimum on the hands array or anymore, right? So we need another way to determine what is the smallest value, the smallest card value from which we have to try to build a group. Because if there is a smallest value in the hands array, that smallest value must be the starting point of a group, right? There's no number that can come before it because it's the smallest. Therefore, it must be the beginning of a group. And that is the technique or the strategy that we're going to follow. We're trying to find the smallest number that has not been used in a group. And then we're going to try to find the next, the consecutive numbers after that. And if we don't find them, that means we have to return false because we weren't able to arrange the cards in a group such that the cards are consecutive. Right, so that was a long story. So the way we're going to approach this, we're just going to iterate over the hands array for n and now n is a potential starting point now for our group, right? However, it's not guaranteed because, well, we didn't sort hand. We want to get around sorting. You could do the sorting if you wanted to, but we're not going to do that here. And instead, what we're going to do is we're going to try to find the minimum starting from that value of hand. And we know that if any number exists in our counters array, it doesn't have a predecessor, it must be the start of a group, not just that. So that doesn't just apply to the smallest number in hands, but to every number that doesn't have a predecessor. So what we're going to do is we're going to decrement start for as long as it has a predecessor. While counter start -1 larger than 0, start equals minus equals 1. So we're trying to find the predecessor until there's none. Now we just iterate over the start value, and for as long as it's not larger than our current value in n. And well, we have to do this. Well, we have to check whether our start value is whether we still have some cards with the value of start available or not. And if we do, that is cool. Then we can just iterate over the numbers from from start to start plus group size. So this is now us picking those numbers. So if counter that position is larger than 0, well, we're going to decrement it, which is equivalent to us picking that number to be added to our group. Now, if the counter is not larger than 0, we have to return false, because that means we could not construct that group that starts at the start value. And we know that start value has to be the beginning of a group since it didn't have any predecessors. Right. So now we increment start at every point. And so what this while loop does is, as long as we have a number that, as long as start has more than one card left, we're going to try to build a group again and again and again from start until we fail, or we've exhausted the number of cards with the value start. Then we're just going to increment it by 1. And we're going to try so far until we reach the value n that we picked from the array. And then we will move on to the next. Right. And then we just, well, in the end, we just return true, because if we reach the end, that means we've iterated over all of the numbers in hand, and we were able to pick, every time we were able to pick a group of size group size, and we've exhausted all of the numbers. So that's why that would work. And now the space and time complexity would be over n time and, well, how much space? O of 1. Wait a second. What are we storing? Well, we're storing the counter, right? Space. So that in the worst case, every number is different. We have also of n space in that case. For n in hand. And right, so it passes the 2 test cases that we have. Now let's submit the entire solution. And it works. So yeah, that's it. So this is a little bit tricky to figure out on your own. But once you understand the purpose of this inner while loop and the purpose of the outer one, why do we even terminate in that case? You can answer that, then you will have understood the problem.